So we're making use of that first graphing grid that you made in order to be able to solve this equation. So in order to solve it then we know we got to turn it into two separate equations. One of them being the left-hand side equation, we're going to do y equals that, and the other one being y equals the right side. So it's going to be y equals 0 for the other. Well, in order to do the graph for the left-hand side, though, right now it's in factored form, we need to put it into standard form so that we can then find the vertex and be able to graph it. So when multiplying out that left-hand side equation, there are three different pieces that we need to multiply through. Pick 2 to multiply, and then multiply by the third. Now, some of you are going to then start by multiplying the 2 into that parenthesis. That's fine. It only goes into one parenthesis, not both, because there's only one 2. Or you might have multiplied the parentheses by each other first, which is actually the way I like doing it, because I can actually do that really fast. So like that would become 2 times x squared minus 4x plus 3. And then we multiply the 2 into everything from there. When you do that, these are the two equations then that you're going to be graphing. And now we do look at actually making the graphs. So for that first one, if I'm going to graph it then, I got to find the vertex. To find the vertex, I use the x equals negative b over 2a. So in this case, that's going to be x equals a negative 8 over 2 times 2. So in this case then, we end up getting x equals 2, because we're doing 8 divided by 4. All right. Once we have that, of course, we plug that back into the original equation to figure out what the y would be. So we're going to be doing 2 times 2 squared. Remember, when doing that 2 times 2 squared, we have to do the 2 squared first, exponents first, and then multiply by the other 2. And so that's going to give us 8 minus 16 plus 6, which is negative 2. So your first point for this one is going over at 2, negative 2, plot the point right there. All right, from here though, I'm not going to go over 1 and up 1 like I normally would for an x squared graph. Instead, I'm going to go over 1 and up how far? 2. Because remember that 2, that a value is a vertical stretch, so I'm going to go over 1 and up 2 on both sides. And then instead of over 2 and up 4, I'm going to go over 2 and up 8. And then draw the curve that goes through those points. Then we're just left with graphing our second equation, y equals 0. Remember, if there's no x, it's just a horizontal line. And in this case, my horizontal line is going through 0. All right, so now we look for our solutions. The solutions, of course, are where they intersect. And so that's happening there at x equals 1 and 3. And notice I am only needing to give the x values here because there is no y in my original equation up here. All right, now that I found that though, what effect did the 2 have on the solutions? So the 2 that's in that factored form, what effect did it have on the solutions? Well, basically none, right? Because remember yesterday we did some problems like this and we saw that basically I just looked to see what can I plug in for x that will make that equal 0. And so that would be 1. Did I have to multiply that 1 by the 2 out here? No. Because notice, my solution was 1, not 2. Same kind of thing over here with the x minus 3. We'd say what minus 3 equals 0. And that's a positive 3. And so notice that a number out front does not change that, because like if I make that first parenthesis equal 0, 2 times 0 is still going to be 0. And so that's not going to be changing how we end up solving those. So with that in mind, we now can look at actually doing a little bit more solving straight up. No graphs needed for these two. So please go ahead and write down and solve each of these. All right, so for solving these, remember if I want to solve a quadratic like this, the first thing I do is I set it equal to 0. Okay, that's done here. We start there in this particular case. Then I now try to factor it. And so in this case, it's just a plain old x squared, so all I have to do is figure out what two numbers add to the middle number and multiply to the last number. And those two numbers are negative 12 and negative 3. Now that I have my factored form, I can now go ahead and solve it. I am setting each of these individual parentheses here equal to 0, which is why it has to be equal to 0 here. So for instance, I'm actually doing x minus 12 equals 0. And it's like I'm solving that all the way through, but most of you probably don't have to write out the algebra for this, right? You could just look at it and say what minus 12 equals 0, and say, oh yeah, that would be 12. Just like we can say what minus 3 would equal 0. And that would be 3. All right, now for the next one. Again, we need to start it by factoring. Now, in this particular case, though, it is not just an x squared, it's a 5x squared. So we need to see how to deal with the 5. Remember, there are two different ways that we might be able to deal with it. The first is we look to see, can I divide every single term by that number, by the 5? Can we divide everything through here by 5? Yes, we can. Because out of the 5, the 25, and the 70, they are divisible by 5. And so what I'm actually going to do here is I'm going to factor out the 5. So I pull the 5 outside of the parentheses, and it's still equaling 0. And so this is what we start with here, where we just factor that 5 out of every single term, and then we look to say what two numbers are going to be adding to the 5 and multiplying to the negative 14. And you should be getting 7 and negative 2. And so that 5 that we pulled out, it just continues to hang out front there. But now we can solve it. Now, my solutions in this case. X is going to equal, is x going to equal 2 or 10 here? Yeah, it's going to be the 2, not the 10. Because what I'm doing is I'm looking at this and I'm saying what minus 2 equals 0, so that's going to be 2. And I do not need to multiply it by the 5. Because remember, if I plug 2 into that parenthesis, then that whole parenthesis there becomes a big old 0. And the 5 times 0 will still be 0. So I don't have to multiply my answer by the 5. I'm just looking inside the parentheses. All right, and then we do the same thing with the x plus 7, where we say what plus 7 equals 0, and so that gives us negative 7. So those are our two solutions that we were looking for. And so the first layer that we added in today was seeing what happens when we have a number out in front of the x squared there that we can just factor out of every single term. Well, we're also going to be looking at the case where that number might not factor out of every single term and seeing what ends up happening there. So this is what we're going to use our other graphing grid for. We're going to be solving this equation by graphing it. So go ahead and write this equation above your next graphing grid, and then we're going to start working it through together here. And the first thing that we always want to do, of course, is we want to get this in a standard form, because then I can actually worry about finding the vertex and therefore graphing it. So I need to start here by multiplying everything in the first parentheses by everything in the second parentheses. Now actually go through and do that piece by piece. Be careful with it, because it could be that you would make an assumption that would throw you off here. So go ahead and multiply all those through. And so when we just multiply everything in the first by everything in the second, we end up here. But then, yes, we can go ahead and simplify. We do want to simplify by combining like terms. So you should be getting 4x squared, the 6x and the 14x combined. So that's going to be plus 20x plus the 21. All right, so if that equals 0, now I can go ahead and split it up into my two equations. So the left side, I'm going to do y equals that. And the right side, I'm going to be doing y equals that as well. Now that we have that, we need to look at graphing. Of course, graphing from standard form means we have to find the vertex. So please find the vertex of that equation now. All right, so we use our x equals negative b over 2a like normal. And in this case, it tells us that x equals negative 2.5. Yes, there is a decimal involved. And just like we always would before, we are now going to have to find our y-coordinate by plugging that back in to the original equation. So, yeah, you'll probably need your calculator for doing this part. but go ahead then and figure out what your y-coordinate is if you haven't already. All right, and so when we do that, we get a y-coordinate of -4. So my vertex then, I know it is going to be at -2.5, -4. So I go ahead and plot that point. Yes, it is at a decimal. Yeah, I just got to deal with that. All right, next up, I think about, okay, now how do I plot my next point? Well, normally I'd go over 1, which, yes, does drop me off on a half, and up 1, normally. In this case, though, I got the 4 in front of the x squared. So instead of over 1 and up 1, I'm going to go over 1 and up how far? 4. And so you go over 1 and up 4, which is going to drop us off right on the x-axis. And remember, that's over by a half. And then from there, I'd normally go over 2. Okay, over 2 would drop me up at that half. And up 4, normally. In this case, though, instead of going up 4, how far up would I go? 16, because, of course, whatever I normally go up, I'm multiplying by that 4 out front, my a value. That 16 is going to be off my graphing grid here. So I don't need to worry about plotting. I can go ahead and draw my graph through those points. All right, and now have my parabola. The next graph is hopefully easy, y equals 0. It is just y equals 0, so again, that's just a horizontal line through 0. I now can look to solve it. All right, so, of course, I'm looking to see where they intersect, so I see 2 points where they intersect. I'm just interested here in my x values, because it's only x's in the original equation up here. And so, what is my first x value there? Let's look at this one here. What is that x coordinate? Yep, that one is at -3.5. Okay, what about the other one? Where's that one at?
-1.5.
Yep, -1.5. Now, in this case, we can bet that that's probably pretty good looking at it, because it looks like that is about where those are. It looks like it's going right through the middle there. And that would make sense considering the vertex was right in the middle. But you could see how we could end up with some really tough to read numbers here, right? Which is the downside of the graphing method. Because when it doesn't happen to give solutions at nice, pretty numbers, we might feel like we're guessing a little bit. So we want to be able to solve it just straight from the equation. And going straight from this factored form is going to be the way that we're going to want to do it. The question is, how can we go straight from this to this? And yes, I will tell you that those are the two that go together there, and that this factored form produces this. Why? Yeah, it's that dividing by 2. Nice. Because, like, if I just said it was 7 here, or -7, like, with what we did yesterday, we might have been inclined to think it was just going to be -7, right? But it wasn't here, because we had to divide it by 2. Well, why would we have to divide it by 2? Well, remember yesterday we talked about how we were setting each of these equal to 0 individually. So, like, I'm taking this 2x plus 7, and I'm setting that equal to 0. Well, if I solve this out algebraically, the first thing I do is I subtract 7 from both sides, which leaves me with 2x equals -7, and then we divide by that 2 that we were talking about. So, divide by 2, and x here equals a -7/2, which is -3.5. Or -3.5 if you prefer. Any of those ways of writing it is just fine. We could do the exact same work to be able to get the -1.5 out of that second set of parentheses. All right, so notice that when there's a number in front of x inside of the parentheses, we will have to account for that number. Knowing that, we now can look at solving these two without having to graph them. So please write down and solve, or at least as much as you can on them, both of these equations. Now when solving this first one, for factoring it, did you notice that the 2 does factor out of everything at the start? Hopefully you're looking for that first. So I would start here by factoring that 2 out of everything. And by factoring out that 2 at the start, it really did make our factorization a lot easier, because for this one, we're just going to be saying what 2 numbers add to 8 and multiply to 15, which of course is 3 and 5. And then once we're to that point, then we can go ahead and finish solving it out. So we just say what plus 3 equals 0. And you should be getting a negative 3 from that. And then we end up saying what plus 5 equals 0. And you should be getting a negative 5 from that one. Remember, the 2 that's out front here does not affect those answers because it's outside of the parentheses. And so that's our final answer. X equals negative 3 and negative 5. A side note here. This is the way that I want your work to look on these. There's a lot of little details that already we're starting to lose, which we need to have in there. Yes, I do want to see this line where we just factored out the number before we jump into this line. Okay? Also, on both of these lines, notice I still wrote the equals 0. This only works if it equals 0. If we start leaving that off, we're going to start not checking that it equals 0. And if we stop checking if it equals 0, we're going to end up running into some trouble along the way. Okay? So this is the way I want your work to look. Make sure you're having those little details in yours as you go. Now looking at the second equation, can I just divide everything of this one by the 2? No. So this is one that's going to be a little bit harder to do. This is the sort where, like if we're using the grouping method, that we're going to start by figuring out what A times C equals and going from there. So you can use the grouping method, do A times C to get negative 20, figure out what adds to negative 1, multiplies to negative 20, and then group from there. Or you might be at the point where you are getting your instincts built up and you can just look at it with a little bit of guess and check. And that's the way I do this one, because the only way to get the 2x squared is 2x times x. So I can know that part right away. And then the only ways to get 10 are either 10 and 1 or 2 and 5. And if I play with those ideas a little bit, if I multiply the 2 by the 2 and then the x by the 5, I can see that's going to give me a 4 and a 5, which are 1 apart. So I can use that. And so I just would want the 5 to be negative, because of course I'm adding to a negative. So I'd make that a minus there, and this a plus here. And so, yes, you can do that with guess and check. And again, the order that you write them in doesn't matter as long as the stuff inside of each parenthesis is the same. All right, now whichever method you use to get there, though, we have our factored form now. Now that we have our factored form, we can worry about solving it. Now the first solution is hopefully very easy. X equals negative 2 from that first parenthesis. Okay, but what about the second parenthesis? I'll tell you one thing that it's not. It's not 5 coming out of the second one. Because remember, if there is a number in front of the x in here, we have to consider it. We have to deal with that number in there. And so, in order to solve this out, unless you can just look at it and know, which I'm not expecting at this point, although you might be there in a week or so, actually solve it as its own little equation. 2x minus 5 equals 0, because we're trying to figure out what can I plug in for x that will make this parenthesis equal 0. And so you can see that we'd add the 5 to both sides, so 2x would equal 5, and therefore we would divide both sides by 2. And when you do that, then you end up with x equals 5 halves, or you could write it as 2 and a half, or you could write that as 2.5. I'm not picky about which way you write it. Go with any of them. I wrote it as 2.5 up here, just because it's easier to type in decimals than it is to type in fractions. All right, now these are the last two problems that we're going to be doing together today, where we're going to be solving each of these. And notice I do want you to write your answers here in exact form. That's a set of directions you're going to be seeing come up a lot from here on out in this class. Exact form basically means you cannot give your answer as a rounded decimal. You could give it as an exact decimal, like 2.5. That's fine. That's still exact. You could give it as a fraction. That's exact. But you cannot round a decimal for it to be exact. So just keep that in mind as we give our answers here. So we're going to solve each of these, and we do it the same way that we've done the other ones. We're going to factor them, and then we're going to solve them from there. So for that first one, we factor it through. You would probably end up using the grouping method here in order to be able to get it. You could actually do a guess and check if your instincts are really getting high there, but most of you probably used grouping still on this particular one. And then once you get to here, then go ahead and find your solutions. All right, and then when we go to solve them, we set each of the parentheses equal to 0. So I'm going to do like 3x plus 4 equals 0, and I'm going to solve that. And then I'm going to be doing 5x minus 1 equals 0, and I'm going to be solving that. Now, when we do that, for the first one, I end up subtracting the 4 from both sides and then dividing by 3. So it's like I end up getting x equals negative 4/3, right? Now, if I do 4 divided by 3, that gives me negative 1.3 repeating. Okay? If you're going to write that one as a decimal, you would have to include the repeating part. Because remember, we're giving our answers here in exact form. So you could give your answer as 1.3 repeating. You could not give it as 1.3 because 1.3 is not exact. Or you could just stick with the fraction. That's what I did. I just went ahead and called it negative 4/3. And that's often the easiest way to do those. And then the other one ends up being 1/5, or you could also have written that one as 0.2. Now here is our factored form for that second one, so if you're having a little trouble finding it, you can now see what it is, and then go to that next step of finding out what the solution actually is. Right, and when we do that, if I leave them in fraction forms, then it's just 3/2 and 2/7. But again, are there other ways that we could write these? Yes, like the 3/2, that's also 1.5, or you could do 1.5. Any of those forms are fine. They're all considered to be exact form. 2/7, well, that one would be a little bit trickier to write in exact form, wouldn't it? Really, the way to write that one in an exact form is to write 2/7. Because you'll notice the decimal there is pretty ugly. That one's going to be a tough one to actually write out. Now they're one of those never-ending decimal kind of things.